Hello, everybody. We're just going to talk about now a little bit about significant figures and decimal places. And the key questions here, what does this mean exactly, and how do you determine significant figures in a number? So if we're just going to look at a figure, like a table like this one, and try to just have like a number of figures, and we want to locate how many significant figures do we have. Look at the first figure on the left-hand side, 7,000. 7,000 is like a rounded to like the 1,000 of any kind of like a quantity. And we can say 7,000 has got, there's no like the decimal point or separator. And here we have like only one non-zero figure here, which means that we have one significant figures. So any kind of like estimations of this quantity can be rounded up to 1,000. So like a 7,000 has got one significant figures. But look at the other one. 7,000 can be written in this scientific form as 7 times 10 to the 3. In that case, we still have one significant figure, okay? There's still no decimal separator. However, if you look at here, we have decimal place or separator here, 7.00 times 10 to the 3. We can say here we have 2 zeros after decimal separators. So in this case, these 2 zeros are counted as significant figures. So the total number of significant figures or significant figures of this digit is 3. If we look at this one, 7.000, we have 4 significant figures, including 7 plus 3 zeros after decimal places. If we look at it on the right-hand side, the change between 7,000, we just add 1 to this 7,000. So we have like a 7,001. This figure has got 4 significant figures, which are 7 plus 2 zeros plus 1. Okay, so we cannot write this figure 7,001 as a scientific form like this one. But if we're just gonna need to just go with that one, we have to just count 1 as well. So still we need to just keep the same significant figures. So if you look at this number, decimal a fraction, like the figure like this one, 0.2300, we have after decimal separator 4 figures. So any numbers or any digits after decimal separator or decimal points counted as significant figures. So in this case, we have 4 significant figures. In here, if you look at here, although we have to count non-zero for the first one after decimal separator, in this case, although we have like the 4 digits after decimal places, but we can move the decimal separator next to the 2 and write it in a scientific form. So in that case, the 0 numbers after decimal places not counted as the significant figure. So in this case, we have only 2 significant figures because we can easily change and remove these decimal places to 2 like the locations on shift on the right-hand side, and we can write it in the form of the 0.23 times 10 to the minus 2. So we have 2 significant figures here. But look at here, we have 1 before the decimal place. Okay, so we have 1.0023. So we have to count all of them as significant figures. So in this case, we have 5 significant figures. Okay, so we just only talk about and use the trick of changing to the scientific notation or form or standard form of numbers. So sometimes you can just write with whatever term you can call this one, scientific form, notation, form, standard form. So it means that you can just write the figure in a form of m times 10 to the 10th, and n's actually. So in this case, for example, 2 can be written as 2 times 10 to the 0. 300 can be written 3 times 10 to the 2. 4,321.768 can be written in this way. 4 0.321768 times 10 to the 3, and so on. So all of them, all of the figures on the left-hand side, decimal notation can be written as a scientific notation on the right-hand side. But the significant figures are the same. For example, the bottom one, we have significant figures here, 3 here. So changing to the scientific form does not change the significant figures. So you can see here. So for all of them, one significant figures, 3 significant figures here, and 3 significant figures here. And the same 2, 2, and for this one, 1, 2, 3, 4, 5, 6, 7, and the same 7 significant figures here, and so on for 2 and 3. So if we're just going to move on and give more examples, for example, for this quantity, decimal quantity of 12.345 can be expressed in different significant figures. However, we have another term of the decimal places. We can say if this figure is accurate to a specific number of decimal places. For example, if we're just going to say, and that brings another larger terms of the precision. Precision, for example, we can have this figure 12.3450 as a larger 6 significant figures. So in some way we can call it the precision is like the 6 significant figures, or it's like rounded to 6 decimal places. Okay, so what if you're just going to say like a precision is 5, it either means that the significant figures is 5, like this one, or it's rounded to 5 significant figures, and so on for other figures. So you're just going to see here. And for the fraction or decimal numbers, so you're just going to see here the figures less than 1. If you're just going to have like a 7 significant figures, or precision is 7, so you can have like a 7 significant figure, non-zero. If it's like less than 1, 1, 2, 3, 4, 5, 6, 7, okay, all of them count as the significant figures. Or you can say rounded to 7 decimal places. 1 is 0, 2, 3, 4, 5, 6, 7, okay, and so on for others. So precision can be expressed in either significant figures or can be presented as a decimal places. So that's like one example we're just going to go through. And one thing that's interesting is that if we're just going to look at here, this figure, if you're just going to say, for example, convert this figure to 4 precision in significant figures, you need to just omit 1 figure from the end or round it up. If you're just going to omit easily here 5, you're just going to have 12.34. However, for rounding up, we have a rule that if the figure is between 0 and 5 inclusive, you have to round up. You have to round up to like the lower value, like 4. But 5 to 10, 5 inclusive actually, you have to round up to the next figure. For example, this figure, 12.345. If you're just going to round up and omit 5, it has to round up to like the 5. It should be like the 12.35. So this is case. And the same for here. If you look at here for 3 decimal places, you're just going to round up to 2 decimal places. 3, 4, 5, because 5 has to round up to the next figure. This figure is correct. So 12.35 is correct one. And the same for here as well. If you look at this figure, so this figure, you have to round up and remove this one, and it's just going to go with 0, 1, 2, 3, 5, rather than this one. So we have another term, which is about accuracy and precision of numbers. So in general term, accuracy consists of 2 terms. One term is the trueness or bias, and proximity to the true value. So for example, if you have if you measure something and compared to the true value, if this line shows represents the true value, and you have a lot of measurements for that sort of the length of something, let's say, all your figures are scattered around this sort of area. And the average of those values, like for example, all like the figures that you just can measure, the average of those values, the difference of that value with the true value is called the trueness, or shows the bias or diversion from the true value. In other terms, we can call it systematic error. The other term or accuracy is called precision. Precision is that how much the value are away or scattered around the average ones. So this is called precision. For example, if you have like a larger scatter, this kind of like a curve will be wider. Okay. So, and in other words, it's just gonna call repeatability or reproducibility of the measurement. For example, if you're just gonna measure that one, how much you are close to the same value. So if you are very like have a very good precision, your standard deviations or scatters are very close to the like the average one. But you might have a systematic error that we can call it trueness or bias. And for the second one, precision, we can call it random error. So this is another term. So based on these, like the very basic definitions, I'd like to ask you to just go through with this a few questions that I'd like you to answer. And we're just going to go through with the answers later on. So first of all, assuming that you have a shooting target, like here, and a shooter has got the 4 shots here, okay? And we're just going to see which statement is correct about the accuracy of the figure, okay? So the accuracy is high or low, okay? Because of what reason? So option A, accuracy is low due to poor trueness, okay, systematic error. B, accuracy is low due to the poor precision or random error. C, accuracy is high due to good trueness, systematic error. And 4, accuracy is high due to good precision, random error. So I'd like you to answer, to think about that. And in the online class, we'll discuss about that. And we're just going to see which answer is correct. To answer this one, just please be prepared. You need to just go to this link, okay, or you need to text this number, any of these options, okay? And once you're just going to text it, you need to just write this one and then choose one of these options here. Text this word to this number with your mobile phone, and then choose one of these options. So what on the other hand, you can just go to the this kind of like the link, and then once you're just gonna this kind of like question is activate, you're just gonna choose any of these options. The second question is another like the shooting target. We have 4 shots again here. A shooter has got something like this. We're just gonna evaluate its shooting. You're just gonna evaluate the accuracy of its shooting. So the accuracy is either high or low. If it's high, option A, due to the good precision or random error, is high due to the good trueness or systematic error, or is low due to the poor trueness because of the systematic error, or is low due to the poor precision because of the random error. So you're just going to see if the shooter is accurate or not accurate because of the what reason, either random error or systematic error, or the good trueness or the good precision or poor precision. Okay, the other question about this that we're just going to discuss about this, we're just going to see which statement is correct about the number of significant figures and accuracy of this value. 1200.0. Okay, option A, we have 5 significant figures for this one, and accurate to 1 decimal places. Option B, 2 significant figures and accurate to 1 decimal places. Option C, 4 significant figures and accurate to 3 decimal places. Option D is 4 significant figures and accurate to 1 decimal places. Please be prepared for this to vote on any of these options once we're just going to discuss it in the class. Thank you very much.